Hi, so today I'm going to talk about the Pragyan Rover, which is the moon exploration rover. So before I would like to start to talk about the Pragyan Rover, I would like to explain what is a rover. So rover is basically a space exploration vehicle which is designed to do some scientific stuff on the celestial body. So today's video I will gonna talk about some of the introduction of the Pragyan rover, and then we'll look at the notable lunar rover, and in that notable lunar rover we'll see the Apollo lunar rovering vehicle, and then the Lunar rovers, and then the U2 rovers, and then we'll go with the Pragyan rover. In that Pragyan rover we'll see the mission objective of the Pragyan, and then some of the operational challenges and the design and structure of the Pragyan rover. In design and structure, we will see the mobility, and then we'll see the power system and the payload and scientific instruments, some of the rocker bogie suspension system, which is also the part of the Pragyan rover, brushless DC motor, and then communication. So here I would like to start with an introduction. So as I mentioned in the introduction, we will see what is the basic role of the rover. So rover is basically, as I mentioned earlier, it's a space exploration vehicle and do some scientific stuff, study some the element analysis on the surface of the particular planets. So that's the role of rovers. So, and then we'll talk about some of the notable lunar rovers. In that we'll see the American Apollo lunar rover vehicle, which is the part of Apollo mission 15, 16 and 17, and it's launched in early 1970.
So here is an image and video of the Apollo 16 mission explaining how it had been driven on the surface of Lunar.
Okay, I'm ready. I'm not going to break it. Let me up to anything. That's on, Mark. That max acceleration? No. Man, you are really bouncing. Is he on the ground at all? That's 10 kilometers. Huh? He's got about 2 wheels on the ground. He's a big rooster tail out of all 4 wheels. And as he turns, he skids. The back end breaks loose just like on snow. Come on back, John. Hey, the deck is running. Man, I'll tell you, Andy's never seen a driver like this. Okay, when he hits the craters and starts bouncing, it's when he gets his rooster tail. He makes sharp turns.
Then Lunar rovers. So there is two Lunar rovers, Lunar 1 and Lunar 2, which is made by Soviet Union. So Lunar 1 is a launch on 1917, which is the first rover to launch another celestial body, and the second one is launched in 1973. So these are the two Lunar rovers. Here is the image of Lunar rovers. The third one is a U2 rover. So it's a part of China Chang'e 3 mission. So here is the image of U2 rover. So where it is over, now we will talk about the Pragyan rover. So Pragyan, first of all, we'll see the mission objective of the Pragyan. So Pragyan is the mission objective of the Pragyan is to study the topography, mineralogy, and then the celestial environment, the lunar environment. That's the base role of the Pragyan rover, and they also exchanging some scientific stuff to the Earth to develop the technology and help for the future scientists to explore the lunar. So that's the role of the Pragyan. So now we will talk about an operational challenges. So while designing the rovers, we don't know the environment condition of the other celestial body. So we should make the robot that's particularly sustain on that surface. So here I would like to talk about some operational challenges that Pragyan have to face. So first of all, I will talk about the darkness. So lunar surface has a 14th Earth day of sunlight followed by 14th Earth day of darkness. So that's the operational challenges. And the second one is an extreme cold temperature. So lunar the night temperature goes up to minus 173 degree, which is very low to sustain some of the parts. So we will make sure that the design should be overcome this extreme cold temperature. And then the radiation exploration. So solar cosmic radiation over there. So we should take care about the solar cosmic radiation also. And then some of the challenging terrain. So we need advanced algorithm to avoid the obstacles. That's the major challenge. And then dust and regolith. The surfaces also have some dust, and which can also damage some optical instruments. So we'll need to take care about this stuff. It's a communication delay. So the communication delay is around 1.28 seconds, which is very large to communicate with the rover while they are in struggle time. I mean, there's some time of obstacles over there to overcome while sending the signal from the ground station. So that's the large time delay. So we need to take care about this time delay. And the last but not the least is the landing and deployment. So landing and deployment is a very crucial point to land on another celestial body, because we don't know the exact idea about the surface of that particular celestial body. So landing and deployment technology should be the very carefully designed, and it should be an accurate. And then this is all about the operational challenges.
Before detailing design and structure, here is a video of all the equipped scientific instrument on Pragyan Rover.
And then right now I'm talking about the design and structure. So in design and structure, we first see the mobility. So mobility include in the Pragyan there is a sixth wheel with independently equipped DC motor which can align the wheel in a particular direction, which are all independent to each other, and then the speed is around 1 centimeter per second. Let's talk about power system. So the Pragyan Rover powered by solar panel, which is charged a lithium-ion battery. So the use of the power panel, particularly on the lunar days, the solar panel will directly power the Pragyan Rover with the solar panel, and then during the night time, that's I have mentioned earlier, the 14th Earth Day of Darkness. At that time, the lithium-ion battery, which is charged by the power panel, is operated, and it's powered to the other subsystem of the Pragyan Rover. So the next one is, and then the payload and scientific instrument. So in that payload and scientific instruments, there is a laser-induced background spectroscope, and then alpha particle X-ray spectrometer, and then high-resolution camera. So the laser-induced background spectroscope used to elemental analysis. So we don't know the particular surface of the lunar. So using this instrument, scientific instrument, we can analyze the composition of the soil.
So here is an introductory video of explaining the principle of laser-induced background spectrometer, and it explains briefly the main step of laser-induced background spectroscope analysis.
Laser-induced breakdown spectroscopy is an atomic emission spectroscopy for the elemental analysis in real time. To analyze a sample, almost no preparation is required, and it's done without contact. A high-energy nanosecond laser pulse is focused onto the sample surface. The high-energy density of the laser light is creating a plasma. By absorbing the laser light, the atoms are ignited into higher energy states. Within some hundreds of nanoseconds, the electrons are relaxing onto outer shells. Then the electrons recombines to the inner shells by emitting light. After a few microseconds, the emitting process is over. The emitted light is collected by mirror optic and guided via fiber to the spectrometer. Light is dispersed by grating and prism on a two-dimensional sensor and converted into a spectrum. A spectrum can consist of thousands of lines. Each peak stands for an individual elemental emission line. The intensity of a line is related to the concentration of the present element. This allows quantitative analysis with prior calibration using reference samples.
Then there is an alpha particle X-ray spectrometer, as I mentioned, is used for elemental composition. So by elemental composition, we know what are the minerals are there, like the carbon, nitrogen, oxygen. We don't know about what is the stuff are there. So that's the instrument which is used to help us to explore the elemental of the soil of the lunar surface. And then high resolution camera. So high resolution camera is used to scan the surface so that we can instruct the Pragyan Rover to go through the soil of the lunar without any obstacles. So for that we use the spectroscopic camera-based 3D vision. So spectroscopic camera-based 3D vision is used to depth the video or image by mimicking the Earth visual binocular systems. So inside this high spectroscopic camera-based 3D vision, the basic principle is that they particularly image that particular part with two different perspectives, like from here and from this side. So from these 2 points, they they image the particular surface or particular parts which vary different angle, and they just scan and they just give the 3D overview of that particular objects. So that's the basic principle behind this. The spectroscopic camera-based 3D vision. And then the second one is a digital elevation model, which is very famous nowadays, because they are used to, 3D scan to the particular surface. So these are done by using LiDAR, some of the photogrammeter, or sometimes the satellite is also the part of this kind of technology, which can develop the 3D model of the particular surface. So in the Pragyan Rover, like you can see in this image, there is an 3D particular area. So after we scanning this surface, the ground station will instruct to the Pragyan, and Pragyan will make the path according to it, and they just follow that particular path without any obstacle. So that's the logic behind this. High resolution camera is also help to image some of the lunar areas. So this all are the scientific stuff on the Pragyan Rover. And this the rocker bogie suspension system. As you can see in this image, the rocker bogie suspension system is in all the varieties of wheels are there, and it's totally worked on the stability. So without any disturbance, we can avoid the obstacle while using this rocker bogie suspension system. There are many much mechanism in it. I'm not going to details about it, and I will talk about then brushless DC motor. So brushless DC motor is the part of the Pragyan Rover, which is also used bounding systems like the rotors and the stators, and it's also integrated with an IC chip which command that electric signal to the rotor to drive a particular direction and particular speed. So there's the use of DC motor. As you can see in this figure, there is a rotor over the stator, and then there's some of the winding over there to produce some conversion from the electrical energy to mechanical energy. So this is the use of brushless DC motor. Now let's talk about the communication. So for Pragyan Rover, they use the Chandrayaan-2 orbiter for the communication. So for example, Pragyan send a signal to the orbiter, and orbiter send a signal to the Earth ground station. So it's act like a relay between those two. So the use of this communication orbiter is to just first exchanging some scientific information from rover to the Earth, and from the ground station to the rovers. So that's all about the Chandrayaan-2 mission, Chandrayaan mission, and they use the Pragyan Rover in that. So this is the rovers, and I have explained the stuff about the Pragyan Rover. So see you all. Bye. That's all from my side.